Okay, I'm going to start the lesson now. Now, last lesson, all look at the board. We'll talk. All look at the board. Last lesson, I talked about Cartesian coordinates, right? Now, all of you look up, don't talk. I say there's something that's called the y-axis and the x-axis, okay? Right? And if I have a point here, this point A will be called 1, 3, right? First number is always what? The x coordinates. Second number is the y coordinates. I said turn your textbook to page 144. I only said 3 times. Okay? Now, if I have a point B here, what should the coordinates be? Negative 3, 2, right? Now, what if I have a point here, C? This one may have some problem. X first, so what is it? 3, 3, 1, 3, 0, right? What if I have a point here? D. 0, 0, negative 1. Are we clear? Are we clear? Okay. Now, then one more thing. What if I have half here and then this point E? What should it be? 1.5, 2. But usually we will put 1.5. Okay, because we thought I'll tell you about scale and we always give it decimal. Because if not, it's very difficult for us to say 1/4 or so on and so forth. Understand? Decimal is easier. Okay? Can? Alright now. Okay, now before I carry on to graph paper and so on, I want you to look at page 145. All of you look at page 145. Here's page 145. Functions. In the previous section, we learned how to use the coordinates x, y to describe the position of a point in a plane. In this section, we will study the relationship between the two variables x and y. Okay. Now, what do you mean by a function? Can you look at page 148 now? Page 148. Function. A function is a relationship between two variables x and y, such that every specified input x produces exactly one output y. The input x and the output y of a function can be written as an ordered pair xy. A function can be represented using words, an equation, a table of values, or a graph. Understand? Okay, I will tell you what's a function. All of you look at the box. Don't look at the text. Supposing I have a box here. Okay? What this box do is that whatever I input as x, come out I will plus 3. Okay, that means this one x go in, this one y comes out. Understand? Okay, it's the box, a magical box, okay? Now, supposing I put in 1. What will come out? 4, right? Can you see it? Okay? What if I put in negative 1? 2 will come out, right? Alright, then how do I represent this? That means when x is 1, y will be 1 plus 3, which is 4, right? Okay? Then, when x is negative 1, y will be negative 1 plus 3, which is 2, right? That is called a function. That's a graphical representation. What do I mean by that? For example, okay, for example, if I plug in a point and it lies on the line, it will satisfy this particular equation. Understand? Points on the line will satisfy the equation. Points outside the line will not satisfy the equation. That means point on the line must have y equals to x plus 3. Understand? Now what do I mean for first? Can you see that y is a bit inaccurate? What is when x is 0? It's 3, right? That means it must actually pass through this point. Can you see? You understand what I'm talking about? So the point that lies on the line must satisfy the equation or satisfy the function. Okay, points that is outside here. Okay, this is outside the line. This is x2, right? When x is 2, what is the answer? 5. So 2, 0 is not on the line. That's why it does not satisfy the function. Everybody clear? Okay, now then I need to say one thing. How do I present this in a table form? All of you look up. I will write y equals to x plus 3. Then I have a table xy. Okay. When x is 1, my y is 4. Can you see? What about my when x is negative 1? Y is 2. So I get an ordered pair like that. I can draw up the 2 points and then I can draw the line. Okay? Now, then let me just say something. In order to draw a line, we actually need 2 points at least. Because if you only have 1 point, right? Can you see any line can go through the point? Okay? Now, when we have 2 points, correct. When we have 2 points, it will create a fixed line. Understand? But usually we will use 3 points. The last point is used as a check, so that the third point also lies on the line. Okay? Why do I say that? Because sometimes the first point you calculate correctly, second point you calculate wrongly, then the line will be wrong. Am I right to say that? Now, if you calculate 3 points and it forms a triangle, of course cannot. It must be a straight line. So that means one of your point will be wrong. You have to double check. Understand what I'm talking about? So, for a straight line, at least 2 points, if you are very confident. If you are not confident, then how many points? 3. What's the third point used for? Checking. Everybody clear with what I'm saying? So, what is the moral of the story? When you are given the function, you are given x, you must be able to find out the outcome, the y. Everybody clear? Okay. Now you take out your notebook. Take out your notebook. I want you to turn to page 150. I want you to know how to present these questions. Okay? Alright. Can you look at question number 3? I want you to take this out of your notebook. Question number 3. The equation of a function is y equals to 4x plus 5. When they give you y, that means they give the outcome. What should be my x? Can I do the first one for you so that you know what's happening? Now, y34 means what? 34 equals to 25 minus 3x, right? What am I solving for now? X. 34 minus 25 equals to negative 3x. What's 34 minus 25? Huh? 9. 9 is minus 3x. So what's my x? 9 over negative 3. Answer? Negative 3. Now, can someone tell me what's the difference between question 3 and 4? Question 3 is I put in x. Y come out is what, right? Correct. How about question 4? I know y comes out is what, but I don't know what x goes in. Then I'm going to find the reverse. Can you see what I'm talking about? Okay? Can you find out what comes from? Negative 5 equals to 25 minus 3x, right? Negative 5 minus 35 equals to minus 3x, right? What is minus 5 minus 25? Yes, minus 30 is minus 3x. X will be 10, right? Minus 30 over minus 3 is 10, right? Do you get 10? Now, how do you actually check your answer if it's correct or wrong? Work backwards. That means what? You put 10 in. You put 10 inside here. 25 minus 30. Is it minus 5? Yes, that is correct. Understand? You can always double check. Are we clear with what I'm saying? Are we clear with what I'm saying? Okay, good. Then I give you 5 more minutes. Can you look at page 151? Question number 8. All of you do it? Yes, now in your notebook. Question number 8. Now it's a bit difficult because now we have what? Fractions. What is the first answer? You should just key in your calculator. Negative 1 1 method. Very good. Now, do you agree part A, 1 and 2 is very straightforward? Because they give you X, they ask you to find what? Y. What about part B? Can you tell me what's the difference? They give you what? Y, ask you to find X. Okay. So, when Y is what? All of you look up. 1 will be 2/3 X plus 1/3, right? So, 2/3 X equals to 1 minus 1/3. 2/3 equals to 2/3 X, right? So what's my X? 2/3 divided by 2/3, right? Answer is what? 1. You can see straight 1, put 1 over there. Can you see the answer is 1? Okay, so what does it mean in part 3? That means when 1 is put in, the answer that comes out, when 1 is put in, the answer that comes out will also be 1, according to the function. Everybody clear? Okay? Alright. Oh, it shouldn't be part 3, right? It should be what? B part 1, right? Then B part 2. Okay, when Y is negative 1/6. Negative 1/6. Oops. Negative 1/3 is 2 over 3x, right? Use your calculator. What's negative 1/6 minus negative 1/3? Do you get a negative half over this side? This is a negative half over that side. Is equals to 2/3 X, right? So if X stays here, use this one divided by 2/3, right? Negative what? Negative what? This divide. Need the answer from you. 3/4. Negative 3/4. Are you okay? Now what does it mean? If the answer come out is negative 1/6, the one that we put in must be negative 3/4. Do you understand? Now, what's the difference between question 3, question 4, and question 8? Do you agree 3 and 4 will be much easier? Why? Why? Yes, we are looking at integers, right? Okay, but question 8, you are looking at what? Fractions. And that's why it's more difficult. Are we clear? Are we clear? Okay, good. Now, next, can we turn back to page 148 again? It is important to specify the input X to completely describe a function. Different inputs produce different graphs, even if the functions are the same. When the inputs are only integers, the graph will consist of discrete points. When the inputs can be any real number, the graph will consist of a straight line, which we will explore further in the next section. When the inputs are not specified, example as integers only, we can assume that it can be any real number. Okay, this one I will talk about it when we go on to graphs. Okay, today we just want to say go in, fraction or integer, come out what's the answer, that's all. Understand? And I told you it's represented by a line, right? Okay, we'll do that later. Okay? Alright, now, next thing that I want you to do is I want to talk about your graph paper. This is your graph paper. Okay? Now, it is very important to understand your graph paper and don't anyhow draw on the graph paper. Okay? Now, I'm going to explain to you what are the functions of the graph paper. In the exam, graph paper will be printed on the paper itself. So you don't have to say, must I go and bring graph paper, so on and so forth. Is that understood? Now, where's my long ruler? The long rulers. Oh, okay. This is the long ruler that I'm talking about. Okay? I need this part with transparent because when you go to set 3, you need to draw a very straight line. Okay? Then you can see where it deviates from the transparent side. If the whole thing is opaque, then it's very difficult to see. Understand? Okay, now, first, I want you to look at the graph paper. All of you take a look at my graph paper. It's exactly the same, just that I enlarged. All of you look at me. Can you see there's a dark green line and a dark green line? Between the dark green line and the dark green line, there are 10 meters square. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see that? Okay? Now, all of you look up here. Between two green lines, that one is actually 2 cm. Dark and dark, 2 cm. Understand now? Uncle, you understand? Dark and dark. 2 cm, understand? So, nobody should say, I don't know what is 2 cm. Understand now? Okay, all look up. If from here to here is 2 cm, how about from here to here? 1 cm. Okay? Now, then we need to talk about the scale of the graph. Okay? Now, I want everybody to look at the board. I don't say this many times. Now, supposing this is the graph paper and I want you to use this scale. 1 cm to 1 unit. What does it mean? All up. That means I must draw a straight line. X, of course, I must use a ruler. Okay? Now, can you see that I always draw on the darker green line? X. Then I draw a vertical line called the y-axis. Look at the x-axis. What's my scale? 1 cm, 1 unit. So 0, 1, 2, 3, 4, and so on. Understand? This will be what? -1, -2, -3, so on. Now, what about y-axis? It is also 1 cm to 1 unit. I will have 1, 2, 3, -1, -2, -3, and so on. Understand? Okay, then students will ask me, must the scale of the x-axis be the same as the scale of the y-axis? The answer is no. Okay? Now, this one, I can have 2 cm to 1 unit on the x-axis. Now, if I say 2 cm to 1 unit, what does it mean now? That means my one will be here. No? Because 2 cm 1 unit, then 2, 3, this is my x. Here will be what? -1, -2, so on. Understand? Now, for scale, we always choose convenient scales. You don't want to choose 1 cm 3 units, then you cannot estimate later. Do you understand? Now, I can also do this. Can you tell me the scale for this graph? What's the x-axis? X-axis 2 cm 1 unit. How about the vertical axis? 1 cm. 1 cm what? Yes. No. 1 cm 5 units. Can I? No. You always go with this. Don't put 2.5 or so ever. Okay. Now, what if I change? What will this be? This one will be what? 2 cm to 5 units. Are you clear? So, it depends on whether it's a small scale or a large scale. Understand? Now, one thing you must remember. All the points must fall inside the graph paper. You cannot say, oh, it's on the paper. So you take a picture, then after that send me the paper. Cannot. Understand? Okay, now then, I need to tell you, because students, when they first encounter graph, right, it looks very simple, but actually it's not. Now, this is your graph paper, okay? Then there is grid on here, right? Then there are 4 sides, right? All of you look up. This one is very, very important. Okay, I want you to look at the board. I'm going to use a different color. Your axis need not always be in the middle. Okay? It's just like when you have a computer, you can shift the thing, right? Translate the thing. So, if your graph paper is like that, and you realize that the points are all at the negative side, you can shift it up so that you can plot all the points. Understand? Or, if you realize that your points are all on the positive side, then you can don't have the negative side. That means it's shiftable. Understand or not? I want everybody to look at the board and not sleeping. Sit up straight. No sun tanning. No heads down. Everybody clear with what I'm saying? Okay, so you can shift it about. Everybody clear? And all lines must be drawn with pencil. Because if it's wrong, you cannot say, oh, I want to pin away. You cannot pin away if it's in ink. Understand? Okay, then one more thing that I need to teach you is to how to read the scale. Okay? Now, before I teach you how to read the scale, I want everybody to look here. Okay? Now, this is the boundary of the graph paper. Now, supposing I give you a very large scale. Your Y you can put outside, but the last scale you must draw is here. Understand? The scale that you plot must be there. It cannot drop out. Understand? Now, likewise for your x-axis, you can draw out, put x, but your last scale, maybe the last scale is 30. It must be on the graph itself. Everybody clear? You cannot say, oh, I'm going to add one more square. No, cannot. Understand? Okay? Now, then I want to look at this one. All of you look, huh? Okay, supposing this is 1, this is 2, huh? All look up. Likewise for the y-axis. Can you tell me what is this? 1.5. So what is this? 1.1, right? How about here? 1.3, okay. Do you agree this is 1.2? Okay, now then I'm going to enlarge this up. 1.2 and 1.3. What if it is halfway here? 1.25. Yes, 1.25. And you can only read to half the smaller scale. You cannot say my eye is vernier calipers. You know, I can read to 1.25. Then your friend say my eye even better, 1.255, you know. Cannot. It's only half the smaller scale. Now, for example, if the line is very near to 1.2, you just say 1.2. You don't say, oh, I agak, 1.21. Then your friend will say, no, it's 1.219, but I better than yours. No, understand? Now, if it's very near to here, what do you say? 1.3. If it's half, it's 1.25. No such thing as, but I very good, it's 1.26, you are wrong. No. Understand? Graph is actually an estimate. Understand? You can only read to half the scale. Everybody clear with what I'm saying? Okay. Now, likewise, if I have 1 and 2 here, it's the same thing for the vertical axis. So I'm not going to explain for the vertical axis. Are we clear? Okay, then we come to another scenario. Okay? All of you, this is 1 and this is 2. How much is 1 square? 1.2, right? 1.4, 1.6, 1.8, 2, right? Okay, I'm going to write here. Alright. Okay. This is 1.1. 4. This is 1.2. What about in the middle? 1.3. Half the smaller scale. Understand? Half the smaller scale. Dependent on your scale. Okay, I'm going to give you one more. This one is a bit difficult. So all of you look up. Okay. Do you agree that if this is 1, this is 1.5, this one is 1.1? This one is what? 1.2, 1.3. I made a mistake. one is a 1 by 1, right? How about this one? 1 by 2. How about in the middle here? 1.155. Okay, this is the problem that I'm having. Keep your mouth shut. Okay? Alright, this is the one that will have a problem. Because this is not half the scale yet, right? This is one scale or one square. 1.15. Then 1.2, right? So, me, I don't know how to do it. What is in half here? 1.75. Rubbish. 1.075. I want to hear it. 1.125. Alright. What about here? Can you see it? I'm talking to you. Alright. Okay, all of you can write. Take your calculator. 1 square is 0.15. Divide by 2. 0.075. Are you sure? 1 square is 0.15. Correct. That means I'm wrong. I'm wrong. Are you sure? I'm wrong. Okay, then I'm wrong. Wait, let me just double check. 1.25, right? No? Yes? 1.075. Yes. My mistake. Very good. You understand what I'm talking about now? Yes or no? Still cannot. Okay. Let me just do it again. It's a good thing that we must discover that the teacher is wrong. Hey, excuse me, when I'm wrong, okay? Understand? We're going to do it again. Understand now? Okay, now it's alright. One more time. Keep quiet. 1.5. Right? Okay, now we do what here. Okay, I'm wrong already here. Like this is what? 1.1, 1.2, 1.3, 1.4, 1.5. Am I right to say that? Okay, I'm going to enlarge it here so that you can see properly. Just now I did enlarge properly, okay? 1. How many square? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1.5, right? Correct? Yes or no? Okay. This is a 1.1. This is a 1.2. This is a 1.15, right? Okay. 1.15. Okay. So, how about it, Bobby? Wait. I don't understand why. Yeah, it's 1.125. That's why I cannot be wrong. Okay, give me a calculator. I teach you, okay? Right? Okay, wait. This is 1 square, right? Okay. 1 square is 1.15 minus 1.1. So what is it? 0.05. Not 0.15. Right now. Okay, so 0.05 divided by 2. 0.0255. So this one is 1.125, right? But how about here? This one, this is 0 point. This is not. This is 0.05. Can you see it's 1.1, 0.05, not 0.15. That's why I made a mistake there. Everybody clear? Because it's only 1.1. So do you understand? Okay. Now, can you see that I must read to half the smaller scale? Understand? I must read to half the smaller scale. Okay. Let us try again. This is what? 1.6. 1.7. This one is what? 1.655. Okay, now I'm going to do it. 1.6, 1.7, 1.65. What's here? 1.625. Very good. 1.675. Can you see? Can you see now? Okay, now I'm going to go to the vertical. Everybody look up. 5, 10. This is what? 6, 7, 8, 9, 10, right? Okay, this is 9, right? How about here? 9.5. What about half? 9.25. Correct. Then here? 9.75. So you must know how to read. Okay, now another one is easier. So what is 9.1, 9.2, 9.3, 9.4, 9.5, 9.6, 9.7, 9.8, 9.9, 10, right? Okay, what if it's halfway? 9.95. Alright. So, I repeat, you can only read to half the smaller scale. Everybody clear? I will teach you more when we go to the next year when we read more graphs. Everybody okay? Alright, good. Now, next thing that we are going to do, okay? Now, can we turn to question number 6? Can you write on your content page? And all of you write on your content page. What is the number there now? Your last entry, I didn't put 5C, right? I don't forward. Your last entry, is it 5B? 5B, right? Okay, give me your file. Let me check your file. 14 should be 5C, correct? I'm talking to the whole class. 14 is 5C, right? Okay, what's the date on your exercise 14? Just now I just give it back to you. 20th of March. Okay? Then this is, I think I put formula, right? Okay, now write 15. Now write 15. Today's date is the 25th. Exercise 6A. Can you write graphs? Okay, then all of you take out one piece of foolscap paper. Not foolscap, one piece of graph paper. Zalida? Hello? Wow. Okay, are you in graph land? Okay, now, all of you look up. Now, can you look at question number 6? It's going to be difficult first time you do it, okay? Now, all of you look up. I'm going to show you on the board. And I want everybody to keep your mouth shut. Look up. On the graph paper, can you write your name? On your graph paper, can you write your name? Your class. And the date. Then, can you write down exercise 6A? Graphs. The date is on the board already. Okay, as long as you label exercise 6A, not you know how to talk, you know how to talk. Are we all clear? Are we all clear? Yes or no? Okay. Now next I'm scale, x-axis, 1 cm to 1 unit, then y-axis, 1 cm to 1 unit. Can you write this for me first? All of you. Scale, x-axis, 1 cm to 1 unit, y-axis, 1 cm to 1 unit. Okay. Now, I say already, all graphs must be plotted with what? Pencil. Okay. I don't want people to do. I want all to look at me. I'll give you time. I really will give you time because this one is the first time I'm doing it. Okay, we look at question number 6. The vertices of a right-angled triangle are A, B, and C given. Plot the points A, B, and C on the Cartesian plane below. Hence, find the area of the triangle ABC. You mean you cannot see my writing? Don't think you can see it. Yes, yes. I make it bigger. Can see it now? Because if I don't do like that, right? Don't do the small one, you cannot see the scale later. Can already? Can, Okay, I'm going to make it small, Okay. All of you look up, What's 1 cm to 1 unit? I want everybody to keep your mouth shut. All of you look at my drawing. I say don't draw. Those who draw, I throw away the block paper you draw again. Now, you draw a straight line. X is only at one side. Understand? Okay? Go first. Don't draw first. Then you draw a vertical line. The arrowhead is only at one side. Can see it now? Yeah. Now, because it's 1 cm for 1 unit, you put a 0 here. Can see? Yeah. Then you put 1, 2, 3, 4, 5, 6, and 7. You draw this 7. The negative side until negative 5. The vertical one you can draw until 6 and 7. The negative one understand? Understand? Okay, now I don't want people to draw. I say already. Look at the board. I say I'll give you time. Look at A. What's the coordinate? 0. No. 1, 0. That means my A is here. Can see it now? Yeah. Must put with a cross, don't put with a dot. Okay. What's my B? 7, 0 is where? Here, right? Yeah. So you must put B like that. What's my C? 1, 6. My C is here, right? Correct? Yeah. What did the question say? Plot the points A, B, and C on the Cartesian plane below. It's a right-angled triangle. So what must I do to the 3 points? I join them and draw a triangle. Can you see it now? Yes. Can you see it now? Yeah. Okay, now I want to know, is that all the question? What did the question say? Find the area. Okay, now hold on first. Listen. Shh. This one we cannot take 6 here. How many units from A to B? 6. 1, 2, 3, 4, 5, and 6 units. How many units from A to C? 6, right? So you can write here area of triangle ABC half times 6 times 6, right? So which will be what? AB, you must put unit square, not cm square. Because sometimes it can be 5, 10, 15, 20. So you cannot put cm square, you must put unit square. Do you understand? Okay, 5 minutes to complete this. Every lesson, how many bond paper must you have? 5. Very good. Now, to my horror, right, I just realized that Thursday is speech day. And you're going to miss next lesson. I know you're very happy with it, but I'm not happy about it. Okay, Thursday is your birthday.
Actually, Wednesday is my birthday.
Oh, yes. Every day is my birthday. Understand? Okay, so what will happen is that on Wednesday, I'll try and finish up this and 6B. Understand? Then 6C, I will do it next week. Are you all clear? Okay, alright. Kayla, can you stop